In this video, I'm planning to explain 1 to the power of infinity as a limit. Here we have 3 conditions for this case. These 3 conditions must be satisfied, then we can apply the 1 to the power of infinity rule. Firstly, limit x tends to x0 fx must be equal to 0. Here, for this expression we are talking about, fx must be equal to 0. This x0 generally it is infinity, and limit x tends to x0 fx must be equal to 0. At the same time, limit x tends to x0 gx must be infinity. So this is going to be equal to 0. This is going to be infinity. So the case is 1 to the power of infinity. Here, the third condition, limit x tends to x0, the same value, fx times gx, if it is equal to k, and k is element of real number, in a real number it should be, then the limit of this expression it's going to be equal to e to the power of k is going to be. Okay, now for solving the question, the first question is 47. For solving the question, we should check all these cases. The first case is limit x tends to x0, which is infinity here. This is the x0 here. x0 fx is equal to 0. It must be. Let's check that one. Limit x tends to infinity fx is 1 over x is equal to 1 over infinity, and that's equal to 0. The first condition is satisfied. The second one is limit x tends to infinity gx is equal to infinity, it should be. Let's check that one also. Limit x tends to infinity x is equal to infinity. Directly we are replacing infinity here, and the result is infinity. The first condition satisfied, second condition satisfied. Now the third one I'm checking. The third one, it says that limit x tends to infinity fx times gx, it should be equal to k. Gx, it should be equal to k. And when I see that one, limit x tends to infinity, 1 over x is the fx. Gx is equal to x is equal to limit x tends to this x and this x. You can simplify here. This one and this one we can simplify, and the answer is going to be equal to limit x tends to infinity 1, which is equal to 1, because when you have the constant number is the limit it's going to be. Also, we understood that k is equal to 1 here. Then the third part is not solution, only we're replacing the values. The rule says x tends to infinity 1 plus fx to the power of gx. All the conditions are satisfied here, so it's equal to e to the power of k. That implies that limit x tends to infinity 1 plus 1 over x to the power of x is equal to e to the power of 1 is going to be, and this is the answer of the question is going to be. Let's solve another question. Here we should define by ourselves what is fx and gx. This expression, what is here, 1 plus form, this is fx, and this one, the power is gx. It's going to be, if you remember from the case. Okay, now here there is fx and gx I put here. Okay, and then we are going to try to find. The first condition is 1. Limit x tends to x0. x0 is here. x0 is equal to infinity. X tends to infinity. fx should be equal to 1. Okay, now we're starting with the first condition. Is limit x tends to x0 is infinity here, fx is equal to 0. We are going to check this case. Let's see, limit x tends to infinity, Here the fx I said it's equal to 2 over 2x plus 1. As you see, when you replace 2 over 2 times infinity plus 1 over, that's equal to 2 over infinity, and that's equal to 0. 2 times infinity plus 1, infinity, it's going to be. Okay, the second one, limit x tends to infinity, gx must be equal to infinity. Let's check this case. Limit x tends to infinity, 3x plus 1 is equal to 3 times infinity plus 1, that's equal to infinity. So these two conditions satisfied. The third one, define the k value. 3 limit x tends to infinity, fx times gx is equal to k. That implies that limit x tends to infinity, and fx is equal to 2 over 2x plus 1 times gx is equal to 3x plus 1 is going to be, and that value is equal to limit x tends to infinity, and here it's going to be equal to 6x plus 3 over 2x plus 1, because this term is going to be multiplied by 2 only. We are going to multiply by numerator only. Okay, what about this one? If you remember the rule for the infinity over infinity, if the powers are same, n is equal to m, the coefficients are going to be a over b is the limit result it's going to be, if you remember that one. Then here the coefficients are, powers of the variables are same, the greatest powers, 1 and 1. So n is equal to m case. That's why the answer it's going to be equal to 6 over 2, which are the coefficients, and that's equal to 3. Also, this is equal to k. The last one is the result part. Limit x tends to infinity, 1 plus fx to the power of gx. If all conditions are satisfied, it's going to be equal to e to the power of k, which is 1 plus limit x tends to infinity, 1 plus 1 over 2x plus 1 to the power of 3x plus 1, it's going to be equal to e to the power of k, which is equal to 3 for the question. Okay, let's find the answer of this question. Here in the question, we don't have 1 plus form, so we are trying to get firstly 1 plus form, and from to get the 1, the numerator and denominator, it should be same. How to make the numerator as 3x minus 1? So this expression is going to be equal to limit x tends to infinity, 3x minus 1. To make 3x minus 1, I need to add 2 to the expression, then to get 3x plus 1. So instead of this expression 3x plus 1, I wrote 3x minus 1, which is denominator, same with denominator, over 2x plus 1. It's going to be over 3x minus 1. Here it's going to be, that's equal to 4x minus 2. Okay, now from the addition of two rational numbers, a plus b over c can be written as a over c plus b over c. That's why I'm going to separate this expression like this. It's going to be equal to limit x tends to infinity, 3x minus 1 over 3x minus 1 plus, I separate the expressions a plus b, or a over c plus b over c, so 2 over 3x minus 1 is going to be the answer, and that's equal to the power of 4x minus 2, and that's equal to limit x tends to infinity 1 plus 2 over 3x minus 1 to the power of 4x minus 2. This is the case that we are looking for, and 1 plus fx to the power of gx it must be, and you know this is going to be fx for us, and this is gx it's going to be. Then we can start to check the conditions. There are conditions, 3 conditions, if you remember. I said 1, that's equal to limit x tends to x0, which is infinity here. Fx must be equal to 0. Let's see that one. Limit x tends to infinity 2 over 3x minus 1, this is the fx value, is equal to 2 over 3 times infinity minus 1, that's equal to 2 over infinity, and that's equal to 0. So the first condition is satisfied. What is the second condition? Limit x tends to infinity, gx must be equal to infinity. Then that's equal to limit x tends to, the gx value is here 4x minus 2, so 4x minus 2 is going to be equal to 4 times infinity minus 2, that's equal to 4 times infinity, and the result is going to be infinity. So the second condition is also satisfied. And the last one is going to be, the third one, it's going to be limit x tends to x0. X tends to x0, for this question it is equal to infinity. Fx times gx must be equal to k. Let's see what is the k value. Limit x tends to infinity. For fx is equal to 2 over 3x minus 1 times 4x minus 2, this is fx times gx, which is equal to limit x tends to infinity, 4x, 2 times 4x is equal to 8x minus 4 over 3x minus 1, and this is infinity over infinity case. When the powers are same, we are going to get the coefficients on it, so it's equal to 8 over 3. Then this is the k value is going to be also, and the last part is only we are going to write the value limit x tends to x0, fx times 1 plus fx to the power of gx, it's going to be equal to e to the power of k. If all these conditions are satisfied, as you see, we checked and all the conditions are satisfied. Limit x tends to infinity, here 3x plus 1 over 3x minus 1 was equal to limit x tends to infinity 1 plus 2 over 3x minus 1 to the power of, that's going to be equal to, let me take a bit right in this expression, I forgot the power here, to the power of 4x minus 2, here also the power is 4x minus 2, which is gx, is going to be equal to e to the power of k, which is e to the power of 8 over 3 is going to be 8 over 3